Okay, everybody, this is a little mini lesson on how to solve a system of linear equations. So first off, a system of linear equations is a set of two or more linear equations with the same variables, like these examples here. This one, the y's are by itself in both forms, so these are in slope-intercept form. These two, neither one is in slope-intercept form, but you can use these just like they are when you solve systems, and I'll show you how in this video. Okay, there are three ways to solve a system: graphing, substitution, and elimination. We're going to start with graphing, then we're going to go over some substitution, and hopefully we'll get to elimination. But these two for sure, we want to look at these especially. Graphing we'll do just a little bit, substitution we'll do more of. Okay, so here's a worksheet that I'm going to start with on how to solve a system by graphing. So right here at number 1, we've got two equations. They both have the same variables in them, and they're both in slope-intercept form. So I am ready to graph from these forms. If they're not in slope-intercept form, you need to put them in slope-intercept form first, so then you can graph them. So as you guys have already learned, that in this top equation, your slope is 2, and your y-intercept is -3. So I'm going to put a dot on my -3, and then I'm going to use my slope, which would be 2 over 1. So I'm going to go up 2 to the right 1, and I'm going to keep doing that so I can make an accurate line. And I'm going to go backwards, going down 2 in the left one, and now I have my line. I can draw a straight line through it as best you can, put arrows on the end, and you've now graphed that line. Now with solving a system, we have to graph both lines. And what we're looking for is the solutions on both lines, for both lines. So the second equation has a slope of -3, and it has a y-intercept of 2. So now I'm going to put a dot on the number 2 on the y-axis. And now I'm going to use my slope, which is -3 over 1. So I'm going to go down 3 to the right 1, and notice I hit this dot that's on that line. So I'm going to circle it. Now I'm going to go down 3 again to the right 1. And I'm going to do the same up here. I'm going to do one more up here. I'm going to do the opposite direction so I can go backwards. 1, 2, 3 to the left 1. So here's my line for the second one. And as you can see, the one that I circled is at the exact point that both lines intersect. And what this means is, if you remember, every dot along this line is a solution to this equation right here. So if I pick an ordered pair on any dot on this line, there'd be an x and a y value that I could plug into this equation, and this equation would be true. On this line, we have the same thing. We have a bunch of dots on this line, an infinite number of dots on this line. If I could pick an ordered pair and plug it into this equation, they would work in this equation. Now, as you can see, this specific dot right here actually lands on both lines. That means this ordered pair will work in both equations, and that's what we're looking for. We're looking for a solution that will actually work in both equations so it suits the entire system. So right now, the solution to this system is the ordered pair of this dot, which happens to be 1, -1. And there's my answer to that system. To check it, I could plug in 1 for x and -1 for y in both these equations, and I would end up with a true statement. So for example, 2 times 1 is 2, minus 3 is -1, which y is -1. In the bottom one, I do the same thing. I'm going to replace x with a 1, so -3 times 1 is -3, plus 2 is -1, which is my y. So I end up with a true statement. Any other dot on this entire grid, any other ordered pair on this grid, will not work in both. It may work in one or the other, but not both. So let's try one more. On this one, my slope is -5/3. My y-intercept is 1. On the bottom one, my slope is -1/3, and my y-intercept is -3. So I'm going to plot the first one with my y-intercept. I'm going to put a dot on my y-intercept. Now I'm going to go down 5 to the right 3. 1, 2, 3, 4, 5. 1, 2, 3. And put a dot. I'm going to go up 5 to the left 3. 1, 2, 3. Oh, I can't. So this is as good as I'm going to get. So I'm going to try to draw it accurately. And now I'm going to try my second one. My first dot goes on -3 on the y-axis. I'll put my dot. I'm going to go down 1 to the right 3. Down 1 to the right 3. I hit that other line, so I circle that dot. Now, if I want to do some more lines, I can use my slope backwards and go up 1 to the left 3. And that's about all I'm going to get. So I'm going to draw my line through, and you can clearly see that it intersects right there at the dot that I circled. So I write down that ordered pair, which happens to be 3, -4. Now, you could always double check your work. My x value is 3, so this is really a 3 here. My y value is a -4. So let's see if this side, when I put 3 in for x, will this side equal -4? Well, -5/3 times 3, the 3's will cancel out. I'll have -5 plus 1, which is -4. So that works. On the bottom one, -1/3 times 3, the 3's will cross simplify. So I get -1 minus 3, which is also -4. So it works. Okay, the next one we're going to do is solving a system through substitution. But first I want to go over kind of what that entails. With substitution, you're actually going to sub in a value for a variable. So you guys already know that if I were to have this equation, and then I told you y was 5, you would just plug in 5 for y and solve for x. Well, now in substitution, you're not going to get just a number value for the other variable. It might look something like this. Well, you're doing the same thing. They're saying that y is 5x. So what you're going to do is you're going to put this 5x where that y is in the other equation. So you're subbing it in. So for example, I'm going to rewrite it down here. I have y equals 2x plus 3. But they told me that y equals 5x. So wherever there's a y in this equation, I can replace it or substitute it with 5x because they mean the same thing. When you do that, you actually have only one variable left in your equation. So I can solve for it. So I can solve for x right now. Now I have x's on both sides, so I'm going to get my x's together. So I'm going to subtract 2x on this side, subtract 2x on this side. I get 3x equals 3. Divide by 3, and I find out that x is 1. So I now know that my x value is 1. And remember, solving a system, just like we did with the graphing, let me just show you here, just like we did with the graphing, our solution to a system is an ordered pair. Well, we need an ordered pair with substitution as well. Well, we only have an x so far. So we know our answer is going to be 1 something because that's our x value. Well, now that we know that x is 1, that means we can plug in 1 into either one of our original equations and plug it in, and we'll find out why. You can use either original equation. You just pick the one that you think looks simplest. Well, I think the second one looks simple in order to plug 1 in for x. So I'm going to go like this. Y equals 5 times 1. Because this says 5 times whatever x is. Well, we know x is 1. So when we do that, we find out that y is 5, and we're done. We have our solution. Okay, now this one looks a little bit harder because our equations are a little bit longer. Our expressions are a little bit longer. So what this means here is you are going to, let me get that a little focused here. Focus very well. See if it'll focus. Now, what this means is that x is 5y plus 3. So that means that in my other equation, I can replace this x with 5y plus 3 because they mean the same thing. So let's try it. So I'm going to start with this equation. 2 times x plus 4y equals -1. Where this x is, I'm going to replace it with 5y plus 3 because they mean the same thing. Now this says 2 times whatever x is. So I'm going to go 2 times whatever x is. Well, I know x is 5y plus 3. Now I put it in parentheses since it's an expression. Now I still have plus 4y. I still have the equals -1. Once I replace that, you can see all I have now is y's. So I can solve for y. Notice I'm going to have to do the distributive property first. So I'm going to have to do the duck. So we have 10y plus 6. That's what I get from the distributive property. I still have my plus 4y. I still have my equals -1. Now I have some like terms on the same side, so I can combine them. So I get 14y plus 6 equals -1. And now I'm going to start solving for y. Subtract 6 on both sides. I get 14y equals -7. Divide by 14 on both sides, and I'll get -7 over 14, which is -1/2. So I just found out my y value. Now, since I know my y value is -1/2, now I have to find out my x. So I'm going to replace -1/2 for y in either one of my original equations. Okay. Now I think the second one actually looks easier because I know I'm going to be multiplying 1/2 to a 4, and that works out pretty good. So I'm going to use the second equation, and wherever my y is, I'm going to replace it with what I know y is, -1/2. I still have my equals -1. So now I get this, 2x. Now 4 times -1/2 is -4 over 2, which is -2. I'm going to add 3 on both sides. I get 2x equals 2. Divide by 2 on each side, and I get x equals 1. So my ordered pair, my solution to this system is 1, -1/2. Okay, now I wish you all were here so you could have caught my mistake and let me know. I don't know why I added 3 on both sides. I'm not sure what was in my head there. So let's just erase this real quick. I should add 2 to both sides. Then I get 2x equals 1. Divide by 2, I get x equals 1/2. That looks better. Okay, so now I know my ordered pairs. X is 1/2 and y is -1/2. Now that would be my solution to this system. And you can tell that using substitution, you might get fractions as answers. And that's okay. You absolutely can have a fraction for your ordered pairs. What this means is on a graph, if you were to graph a system and you ended up as the solution was 1/2, that means where your lines cross are going to be midway, maybe inside of a square. That's why graphing isn't as accurate if your solutions are going to be fractions. And that's usually when teachers start using a graphing calculator. For our purpose in 8th grade, any graphing that we will do will always land on a perfect intersection with whole numbers. Now, though with substitution and elimination, we absolutely can get our fractions. And that's okay because we're not going to graph it on paper. Okay, now here's our last one called elimination. Elimination is used when you have two equations that look like if we added the equations together, the entire equations together, that a variable would get eliminated. So as you can see, both of these are in standard form. They're not in slope-intercept. They don't have a variable by itself. But when I line them up together, I can tell that if I were to add each column together, my y's will get eliminated because it's 3y plus a -3y is 0. And that's what you're looking for, elimination. And you kind of look ahead of time in your equations if you think elimination might be your best option instead of doing substitution or graphing. If you had to graph or use substitution, These would need to be rearranged and you'd have to get a variable by itself. But with elimination, you can use these two equations right away. So what I'm going to do is I'm going to add these two equations together, just like you add like 2, 3, 4-digit numbers together. I'm going to add each column. So here's a 1x plus another 1x, which is 2x. The 3y plus a negative 3y completely disappears. It turns to 0. So the y is gone. The negative 2 plus 16 is 14. Now I have 2x equals 14. If I divide by 2 on both sides, I end up with x equals 7. Now I have my value for my first number in my ordered pair. I know my x is 7. Now I can substitute 7 into either one of these equations, my originals, and solve for y. So I'm just going to pick the top one. Here's my top one. Instead, it was x plus 3y equals negative 2. Where the x is, I can replace it with 7 because I know x is 7. So I go 7 plus 3y equals negative 2, and I solve for y. Subtract 7 on both sides. I get 3y equals negative 9. Divide by 3 on both sides. I find out y is negative 3. And you're done. If you were to graph both those, this is where they would intersect. Okay, here's one more example about elimination, but it's slightly different. If you can tell looking at these equations that if I were to add these equations together, they would not, no variable would get eliminated. So what that means is you are going to have to tweak one of them or both of them in order to do so. Now, there's one other way to think about it, but let's go through this first. Right here, I can tell that if one of these 4y's was negative, then I could easily add these two together and my y's would get eliminated. So how to do that is I'm going to have to multiply negative 1 to the entire row, either one. Since they're both positive 4y's, I can either multiply this entire row up here by negative 1 or this entire row down here by negative 1. You have to do the entire row because doing something to everything, multiplying something to every object in that equation, as you already know, just creates an equivalent equation, just like with fractions. If you do something to the top and the bottom, you're creating an equivalent fraction. So I'm going to create an equivalent equation by multiplying everything in the bottom row by negative 1. So that means everything gets multiplied by it. So don't forget you have 3 things here to multiply by negative 1. So this one will turn into negative 7x minus 4y equals positive 14. Now the top row, I don't have to change at all. It's good as is just because these both had positive 4y's. Now I can add my sentences together, my equations together. Well, 3x plus a negative 7x is negative 4x. My y's completely cancel. They're out. Negative 6 plus 14 is positive 8. Divide by negative 4 on both sides, and I find out that x is negative 2. So I know my answer is going to be negative 2 something. So now I need to plug negative 2 in for x in either one of my originals. Now I'm going to choose the top one only because it has smaller numbers in it. So it looks a little simpler to me. So I'm going to do it right here in the corner here. So I'm going to replace I'm going to replace the x. So it's 3 times x, but I know x is negative 2 now. Plus 4y equals negative 6. This is negative 6 plus 4y equals negative 6. I'm going to add 6 to both sides. I get 4y equals 0. Divide by 4, and my y equals 0. So I know it's negative 2, 0. So I know if I were to graph these two lines, if I got them in slope-intercept form, graph them, they're going to intersect at negative 2, 0. Okay, those are the 3 ways to solve a system. So hopefully that makes a little sense to you, and we'll practice it in class.